Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Stroke survivors who had ceased to benefit from conventional rehabilitation gained clinically significant arm movement and control by using an external robotic device powered by the patient's own brains. The results of the clinical trial were described in the journal NeuroImage Clinical. José Luis Contreras-Vidal, director of the Non-Invasive Brain-Machine Interface Systems Laboratory at the University of Houston, said testing showed most patients retained the benefits for at least 2 months after the therapy sessions ended, suggesting the potential for long-lasting gains. He is also Hugh Roy and Lillie Cranz Cullen Distinguished Professor of Electrical and Computer Engineering. The trial involved training stroke survivors with limited movement in one arm to use a brain-machine interface (BMI), a computer program that captures brain activity to determine the subject's intentions and then triggers an exoskeleton, or robotic device affixed to the affected arm, to move in res. The device wouldn't move if intention wasn't detected, ensuring subjects remained engaged in the exercise. Using robotics in rehabilitation isn't new, said Contreras-Vidal, co-principal investigator of the trial and a pioneer in non-invasive BMI systems. But robot-assisted exercise doesn't generally engage the user, which is critical for taking advantage of the brain's plasticity to allow patients to relearn movement. This project ensures the brain is engaged, he said. We know that if the arm is moving, it's because they are commanding it to move. That's a very powerful concept. By testing the subjects over a period of time before the trial began, researchers were able to ensure that any changes or improvements were due to the intervention. In addition to better arm movement, the researchers reported that the subjects also showed improvements in using their hands. This is a novel way to measure what is going on in the brain in response to therapeutic intervention, said Dr. Gerard Francisco, professor and chair of physical medicine and rehabilitation at McGovern Medical School at the University of Texas Health Science Center at Houston and co-principal INV. This study suggested that certain types of intervention, in this case using the upper robot, can trigger certain parts of brain to develop the intention to move. In the future, this means we can augment existing therapy programs by paying more attention to the importance of engaging certain parts of the brain that can magnify the response to therapy. The trial was conducted at TIRR Memorial Hermann, where Francisco serves as Chief Medical Officer and DIR. The project was a collaboration between UT Health, TIRR Memorial Hermann, Houston Methodist Research Institute and Rice University. In addition to Francisco and Contreras-Vidal, who is also director of the Brain Center, a NSF Industry, University Collaborative Research Institute, researchers involved with the project include Nikunj Abigat and Zachary Hernandez with Nurai Yazbatiran and Rupa Paranjape with UT Health, Dr. Z. Amelie is also director of rehabilitation engineering at TIRR Memorial Hermann. It was funded by the National Institute of Neurological Disorders and Stroke and Mission Connect, part of the TIRR Foundation. Those of us who have studied the brain for so many years have anticipated that its powers, combined with robotics and the brain-machine interface, could offer unimaginable benefits to stroke survivors and other patients with brain injuries, said Grossman, professor of neurosurgery at Houston Met. This study is just the beginning of what will be possible to treat stroke, spinal cord injuries, and other traumatic brain injuries in the future. The trial spanned a period of several years, partly because it took time to find subjects who met the criteria and were both interested in participating. Ultimately, 10 subjects between the ages of 41 and 71 were enrolled. The therapy took place 3 times a week for 4 weeks. The final follow-up testing was conducted 2 months after therapy ended, and Contreras-Vidal said it's unclear if the benefits will persist long-term. That leads to an ongoing project. Contreras-Vidal has a National Science Foundation grant to design a low-cost system that would allow people to continue the treatments at home. If we are able to send them home with a device, they can use it for life, he said. Story source: materials provided by University of Houston. Original written by Jeannie Kever. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.